Hello, algebra students. Welcome to this video covering exponents. We are about to enter topic 6, which is on exponential functions. So we wanted to do a short 2-video lesson on exponents and the exponent rules that you might have learned back in Math 8. Okay? So first thing here, what are exponents, right? So if we take a look at this expression here, x to the mth power, this x is what we call the base. It's typically a big, it's a big letter, right? X, not a capital letter, but a big letter. Versus here, this m is a smaller letter up above the x. This is where the exponent goes. Now, sometimes we also call the exponent the power, right? So again, interchangeable. So this is x to the mth power. Is how I would say this, x to the mth power. So exponents are all about multiplication, yes? So what this means is you're going to take x and you're going to multiply it by itself m times. That's what exponents are, right? You're taking whatever the base is and multiplying it by itself m, or the exponent, times. So now you'll see in every slide that I do today, I'm going to start with variables, and then we'll use a numeric example. So 4 to the second power, or 4 squared, is what we call this. Okay, so this would be 4 times itself 2 times. So 4 times itself 2 times. Well, 4 times 4 is 16. That's what 4 squared is. Now, there is a strong urge to do this. You think that 4 to the second power is 4 times 2. This is wrong. Yes, I know it involves multiplication, but why not just call it 4 times 2? Why make that too small? Because it means something different, right? So 4 to the second power is not 8. This is wrong. This is wrong. Do not do that. It's not multiplication of the two numbers. It's the base multiplied by itself that number of times. Okay. Now I want to do a quick breakdown of 3x versus x to the third power. So we've been talking about combining like terms in doing 3x. So 3x is equal to 1x plus 1x plus 1x. This is combining like terms, right? 1x plus 1x plus 1x is 3x. What we're moving towards is x to the third. What we mean by x to the third is x times x times x 3 times. This is where we're heading right now, multiplication. All right, so be aware of the differences. Okay, so that was your breakdown of what are exponents. So now let's talk about some of the properties or the rules involving exponents. Okay, the first property here, product of powers. So if we have x to the mth power times x to the nth power, what this means is we have x times x times x m times, right? Mx is here, right? That's the red. And then we have times x times x times x n times, and that's the x to the nth there. So what this means is you have mx is being multiplied, you have nx is being multiplied. What you have in the end is x to the, and you have m plus n x's. This is what this rule means. If you have two bases that are the same with their exponents being multiplied together, you add their exponents. All right, so let's talk about what that means down here with these numbers, right? So 4 squared is 4 times 4, 2 times, times 4 to the third, which is 4 times 4 times 4, 3 times. And what that means is you have 1, 2, 3, 4, 5 4s being added to, being multiplied together. That's 4 to the fifth power. So again, when you see 4 squared times 4 to the third, you can simply do 4 to the second plus third power, which is 4 to the fifth. And that is the same as that, and that checks out. So this rule is verified down there. Okay, so let me verify that in green. So again, if we take 4 and we add the exponents, that is 4 to the fifth, which is the same as above. So that's your first property. Okay? All right, next. We have the quotient of power. So quotient is the answer to a division problem. So here we have x to the mth over x to the nth. So we're doing x times x times x. There's m of them up here on the top. On the bottom we have x times x times x. There's n of them down here. Let me do that in blue. Sorry. So down here we have x times x times x. There's n of them down here. So what we're doing here is we're looking at the x's on top, the x's on bottom, and what we're going to do is we're going to end up canceling some x's. We're going to cancel, we're going to cancel. So what we're doing here is we're taking the number of x's on top and subtracting the number of x's on bottom. And this is what your property is going to say. If you have a quotient or a fraction of two like bases with different exponents, you're going to subtract the exponents, top minus bottom. All right, so let's talk about two situations. Let's do this one first. So 4 to the third divided by 4 to the second, that is going to be 3 4s on top and 2 4s on bottom. So if we cancel the common 4s, notice that we have 1 4 left on top. Since your denominator is gone, the denominator becomes a 1, but we don't need to put 4 of a 1. It's just going to be 4. So if you apply the rule here, 4 to the 3 minus 2 power is 4 to the first, and 4 to the first is 4. So that is correct. Now over on the left-hand side here, we have 4 to the second on top, which is 2 4s, and 4 to the third on bottom, which is 3 4s. So now a 4 cancels, a 4 cancels. Now your top has all canceled out. It's going to become a 1. And because the top is a 1, we need that 1 to stay, and then the 4 stays in the bottom. Do not magically bring that 4 up to the numerator, because that's not correct. And again, if we apply this rule, this would be 4 to the 2 minus third, which is 4 to the negative first. Now later on, actually the very last slide in the next video, we're going to talk about negative exponents. This negative exponent actually flips this 4 upside down. So again, this negative exponent is going to be property number 7 for us. But again, you get the same thing 1/4. You got to believe me on that one. So this is the quotient of powers rule. Okay, and last but not least, you have your power of a power. So notice we have a base raised to an exponent, and then that whole thing is raised to another exponent. So what this means is we're going to take x to the mth, and we're going to multiply it by itself n times. Right? There's n as the outside exponent, so we're going to multiply it 3 or n times. So what this means is we're going to add all of these m's. So we're going to have x to the mth plus mth plus mth. And we're going to add those m's n times. Right? Because this is now becoming the product of powers rule, right? Where you have all the same like bases, all these m's, so just keep adding the m's. Well, if you have n m's being added together, that is x to the m times n power, or x to the m n, however you want to write it. So that's what this rule comes out to be. If you have a power raised to a power, you simply multiply those two powers. That's it. So down here, let's use an example. So 4 squared to the third power. So that's 4 squared times 4 squared times 4 squared, 3 times, right? Well, if we add those exponents, that is 4 to the 6th. 2 plus 2 plus 2 is 4 to the 6th. If we apply the rule, and we just multiply those, 4 to the 2 times 3, and 2 times 3 is 6. You get that coming out. So the rule works. Okay, so there was our first video on these properties of exponents. Second video is coming up right next.